Today we're going to look at how we can make predictions or make guesses about what might happen next or guesses about our data, and that's called probability. And it's expressed as a ratio. Fractions, yay! It's a ratio that measures the chance that an event occurs. And we have what we call desired events or successes, things that we want to happen, and we have failure outcomes, things we don't want to occur. For instance, if I want to know the probability of flipping a coin and getting a heads is my success side, and tails is my failure side. So I look at all of the sample space. That's important also. Then that's the set of all the possible outcomes. That's the sample space. And let's look a little closer. As we get closer to 1, the more likely an event is to occur. So the probability of rolling a 1, 2, 3, 4, and 5 on a dice is 5 out of 6, and that's a lot closer to 1 than the probability of just rolling a 1 on the dice, which is 1/6. So we're a lot more likely to roll a 1, 2, 3, 4, or 5 than we are to roll a 1. And today we're going to look at the probability this way. Probability of success is equal to the number of successes divided by the number of successes plus the number of failures, or all the possible outcomes. This is the successful outcomes over the possible outcomes. And we're going to move past the flipping of the coins and the rolling of the dice, and we're going to look at some more complicated sorts of problems. And here we are. We got John. He wants to put up some pictures on his Facebook page. He wants to put up 2 pictures specifically, and he's narrowed it down to 4 pictures of his girlfriend and 3 pictures of he and his friends skateboarding. All right, so what is the probability that he chooses 2 of his girlfriend pics? Now, if he's a smart man, that's probably 100%, but probability of 2 girlfriend pics, well, there's 4 girlfriend pics out of 7 total pictures for the first choice. And once he's chosen that first girlfriend pic, there's only 3 more left, and there's only 6 pictures left. So 4 over 7 times 3 over 6 is 12 over 42, and that reduces to be 2/7. Now the probability of picking 2 friends pics. Well, there's 3 friend pics out of the 7 to start with. If he chooses one of them, then there's only 2 friend pics left and only 6 total pictures left. So we multiply those together. 3/7 times 2/6 is 6/42, which reduces to be 1/7. In this last situation, we got get a little more complicated, because theoretically he could put his girlfriend's picture on the left and his friend's picture on the right, or he could put his skateboarding friend's picture on the left and his girlfriend's picture on the right. So we got 2 possibilities: girlfriend then friend, and friend then girlfriend. So the probability of him choosing girlfriend and then friend would be 4 out of 7 times 3 out of 6. Plus, and we have to add them together since there's 2 ways, or he could have chosen the 3 of the 7 skateboarding friends pics times 4 out of the remaining 6 pictures, which would be the girlfriend pics. And if we, of course, 4/7 times 3/6 is 12/42. 3/7 times 4/6 is 12/42, and altogether that's 24/42, which reduces to be 4/7. Another way of looking at it is if we can find one of them being 12 over 42, then we know that 2 of them would be 24 over 42, or 4/7. Next situation, Joe and his buddy got a selection of movies, 28 movies. 12 of them are westerns and 16 of them are fiction, science fiction. And he and his buddy want to watch 3 movies on Saturday night. Find the probability of each. Well, what's the probability of him getting 3 westerns? Well, there's only one way he can do that: western, western, western. So that'd be 12 out of 28 times 11 out of 27 times 10 out of 26. There's 12 to start with. When he chooses one, there's only 11 left. When he chooses another one, there's only 10 left. And he starts with 28 movies, selects one, there's 27 left, selects another one, there's only 26 left. Multiply the numerators, multiply the denominators, and reduce, and you get 55 over 819. I think it's 24 that goes into the top and the bottom. Next situation, choosing 2 westerns and 1 science fiction. And you can see there's 3 ways that this can occur. Science fiction, western, 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 science fiction, western, or western, western, science fiction. And here are the probabilities. 16 out of 28, science fiction. There's only 27 movies left. 12 of them are westerns. He chooses a western. There's only 11 westerns left. And there's only 26 total movies left. Multiply the numerators, multiply the denominators, and you reduce, and you get 88 over 819. If I'd chosen Western, science fiction Western, you can see here 12 over 28, 16 over 27, 11 over 26, which also equals 88 over 819 reduced, and 12 over 28 times 11 over 27 times 16 over 26 is also 88 over 819 when you reduce. And if you think about it, we have the same denominators every time, 28, 27, 26. And we have the same numerators every time, 16, 12, and 11. And it doesn't matter what order we multiply in, it's going to be the same answer. So really, all I would need to do is make sure I knew how many ways that it could occur. In this case, there's 3 ways that it can occur. And then I take the result for 1 and multiply it by 3. So 3 times 88 is 264, divided by 819 is 88 over 273 when reduced. Next one, what's the probability of picking 3 comedies? Look, 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 look. How many comedies we got up there? Looks like 12 westerns and 16 science fiction, so the probability is 0. How about the probability of choosing 2 westerns and then 2 science fictions? Why is that 0? Tell me why it's 0 as an Edmodo post.